Okay, folks, we're about to get started here. Today we are going to take a look at equations or formulas used for non-right triangles. So previously we had talked about sine, cosine, and tangent ratios. Okay, those are known as the trigonometric ratios. Those ratios are used only for right triangles. When we get to non-right triangles, then we have to take a look at the sine law and the cosine law. So in the case of each, there's different situations when you can use them. In the case of the sine law, what we're looking for is a triangle. And to note that the sine law will work in a right triangle just because the sine of 90 is 1 and it kind of just allows it to work. But in the case of the sine law, if we're given a triangle A, B, C, and then our sides, our opposite sides are always labeled with the lowercase of the angle. So lowercase a, b, c. So what we're looking for is a situation where we have a pair of sides and their opposite angles. So you have to have two sides and two angles, and they have to be the pairs of opposite sides and opposite angles. So you want a situation where you can circle them. If you could circle them like that, then you have all the information that you need to use the sine law. You'll either be looking for a missing side or a missing angle. In either case, you can use that. In the case of the cosine law, and I've written both versions of it here, the way to find an angle, the way to find a side, and the way to find an angle. A lot of times, this is the one you know, and then you just rearrange this to solve for the missing angle, and that's all this version is. It's not a completely separate equation; it's just a rearrangement of it. But in the case of the cosine law, what you're looking for is three sides and an angle in between, or that should be a B, and that's an A. So you're looking for three sides, and then if we're working with this angle, so if this is our focal angle, then we need all three of these sides. Okay, and it's this pairing of the opposite angle and side. So we need to know the two sides and then the angle contained in between those two sides. If we're looking for a side, or if we're looking for an angle, then we just need all three sides. So if you're looking for if you have all three sides, you can find any angle. The only way you can find a missing side is if you have an angle contained in between two sides. It has to be adjacent to both those sides. You can find the opposite side. So that's kind of the quick review of those. So some questions that I had assigned out of the textbook there were from 8.1, 8.2, and 8.3. The cosine law was divided up into the two sections for sides and angles. Probably not needed, but we'll take a look at a few of those questions together. And then again, if you have any questions along the way, feel free to shoot me a message on EdsB through the chat on YouTube here, or shoot me an email. And you can do so, email or EdsB outside of this time as well. So taking a look at let's take a look at the basic sine law. We'll look at 1A. So in question 1A, I'll just draw out the triangle here for us. We were given a non-right triangle looking something like this. We had side C, side A, side B, or sorry, angle B, A and C. And then the angle was 71 degrees here. It was 53 degrees here. And then we were looking for side A. So this was the value we're trying to find. So that's the general setup of that question. And so again, with the sine law, we need to have those opposite sides and angles. So because we're looking for side A here, we have to have angle A. It's not explicitly given, but recall that whenever you have a triangle, angle A is going to equal 180 minus those other two angles. So 180 minus 71 and minus 53. And that's going to get us 56 degrees. So angle A is 56 degrees. So I can put that in there. And now I have enough. Oh, sorry, I mislabeling that side there was 4 centimeters. So now I have enough information to actually solve this using the sine law. So I can use the A and the B portions to solve for that. So I'll do A over sine A is 56 equals B, which is 4, over sine B, which is 71. And so I set it up like that. I like to get rid of the sine portions, convert those to ratios. So again, if you're using your calculator, make sure the calculator is in degree mode. If it's not in degree mode, then you will get the wrong answers because you're going to be working generally in radians. And again, a lot of calculators tend to default to that that aren't the store-bought calculator. Again, you can also use that handy chart that I provided. I tend to use this. I find it's less prone to error, unless I'm looking for something very exacting, and then I would use the calculator. In most cases, though, the sheet is perfectly fine. But if we rewrite this, A over, and sine 56 is going to be 0.8290, and then 4 over sine 71, which is going to be 0.9455. So we just fill that in, and then we'll take this value over here, we'll multiply with that ratio on the other side, and then that'll give us our A value. So we have A equal to 4 divided by 0.9455 times 0.8290. And we just multiply that out, and divide and multiply that out, and we will get ourselves the solution. And in this case, it is 3.5. So A equals 3.5 in this case. Something you can do as a check when you're doing these, just to make sure you're doing things right. If we take a look at the angle 71, it's a larger angle, so the distance from A to C should be larger than the distance from B to C, because angle A is a smaller angle. So we did get a smaller side here, so that makes sense as an answer, so that helps. It's just a light check as to if this works or not. So that's the general sine law setup. In the case of finding a side, if you're finding an angle, all it really is that you're going to have a missing value here. You'll still do the cross multiply and rearrange the equation until you get down to needing to just look up that ratio to convert it to an angle in the table or on your calculator. Just to do one more with the sine law, let's take a look at question number 10 out of the book. So let's flip over to that here. And question number 10 has a small commercial plane and a jet airliner are 7.5 kilometers from each other at the same altitude. From an observation tower, the two aircraft are separated by an angle of 68 degrees. If the jetliner is 5.2 kilometers from the observation tower, how far is the commercial plane from the observation tower to the nearest tenth of a kilometer? And we're given a diagram here. So we can now find that missing side using that diagram. But the problem here is that we don't have the angle opposite the side we need. So we need that the angle at that jet corner, and we don't have that, so we're going to have to do the sine law twice here to actually solve this. So I'm just going to quickly draw this out. And I'll switch back here. So I'm just drawing this out really quick. So we had 7.5 along the top here. We had 5.2. We had the jet here. We had the tower here. And then our plane over here. And this is what we're trying to find. But again, we don't have this value. We need this angle. Actually, we don't have much other than the 68, so we don't have enough angles to just do the subtraction like we did previously. So we're going to have to use the sine law twice. We're going to have to use the sine law to find angle P. We can find angle P because we do have these pairs. Once we find angle P, we can then find angle J, and then we can use the sine law again to find that missing side. So what we'll do here is, because we're looking for an angle, you can actually put the sine A on top. So you can write the formula out like this. Doesn't matter if the sides or the angles are on top, as long as it's all sides on top or all angles on top. So you can actually flip it around. This just saves it a little step, makes it the manipulation the same as the previous question. So now I'll just fill in, I'm looking for angle P, so I'll call that sine P here over the 5.2, and then sine 68 over the 7.5. So I'll put those in. And then again, same idea. We're going to convert this sine 68 here down to its decimal equivalent, and the sine of 68 is going to give us 0.9272 over 7.5. And now we can just cross multiply that, and when it works out all together, so I'm just going to skip a step of writing it down here, just to make this a little bit of a shorter video, because it can drag on. 0.9272 divided by 0.75, and we get, so our sine P, nope, I already have it there. Sine P here is 0.6429. So angle P, I can use again my calculator. Use the second or shift sign button, or in the case I'm just going to pull it off my table here, and this is approximately 6.4 is about 40 degrees. So angle P, 40 degrees. So this here is 40, and then again we just use the sine law now, or sorry, we subtract from 180, and we'd be left with, what we got here, 108. So we'd be left with 72 degrees in here now. So we got 72 degrees up there, and then we can use the sine law again to solve for our missing side. Actually, we didn't need to. That's 40, sorry. This is 40 degrees. That's 72. I did that backwards. There we go. Okay, sorry. So we calculated angle P, 40 degrees. That's 72 over there. Now that we have that, we can use that pair. So we could do 68 and 7.5 and the 72 and the missing side, and calculate that all out. So again, we do that same setup. I'm going to skip over that so we can move on to some of the cosine stuff. Again, if you have questions afterwards, feel free to ask, and I can take up those specifically. But let's move on to some of the cosine questions. And so in the case of cosine, we're going to take a look at we had 2, 4, 7, and 10 were the questions from the finding sides. So we're going to take a look at question number 4 and 10 from 8.2. So question number 4, we flip over here to the textbook. Question number 4, solve each triangle, round answers to the nearest unit. So we're given an angle in between two sides, and because we want to solve the triangle, that actually means we want to solve everything in the triangle. So when you hear the words, when you see solve a triangle, it means find every missing value. So we'll use the sine law here as well as the cosine law when we're working through this. Or you could end up using the cosine law twice. So we'll start by finding, because we have a side, or two sides with an angle in between them, and we can find this opposite side. So we can find side PQ in this triangle. So I'm just going to redraw a triangle here quickly to illustrate this one. So we have 70 degrees, 15, 13, and then this is what we're going to look for first using the cosine law. So all we're doing, filling in the cosine formula. So we have a squared equals, and actually I'll use r squared in this case because we're looking for side r here. So we can say r squared equals the other two sides squared, 15 squared plus 13 squared. And it does look like the Pythagorean theorem because this formula is derived via the Pythagorean theorem in portion. You can take a look at your textbook for an example of how the formula is actually fully derived if you're interested. We just fill in all the values. So there's the two sides twice, and then our cosine of our angle, cos 70. And so now it's just a matter of being careful that we calculate this correctly, that we do the multiplication before the subtraction. If you want, you can actually just fully type that whole thing in your calculator in one go. So you can do 15 to the power of 2 plus 13 to the power of 2 minus 2 times 15 times 13 times the cosine of 70 and get 260. And if you have a calculator with a display like this where you actually can see what you've typed, this is actually probably the quickest way to do it, most convenient, and less likely to make an error as you're doing a step-by-step kind of process. You may accidentally subtract or add at the wrong point. Anyways, the last step here, we've got to take the square root of 260, and the square root of 260 is approximately 16, and it does say round your answers to the nearest unit, so we'll use an r of 16 here. So we've now found our r side, so this is equal to 16. Now we got to go about finding the missing angles. And so what you can do in that case is, and I'll just set it up here, I won't actually calculate it, but I would just use the sine law here. So we'll find this, we'll call this one, this was labeled P and Q. So to find P, I would just do sine P over 13 equals sine of 70 over 16. So I just solved that using the sine law. That'll give you P. Once you know the P, you can subtract 70 and the P value from 180 to get the Q value. So that would be the general setup. And a lot of times when you're working with these, you may need to make use of a combination of sine and cosine laws to calculate all the missing values in your triangle, depending on what you're explicitly given. Now the other one I want to take a look at, I believe I made, number 10. So we're going to take a look at, did I say 10? Was it 10 on this one? Yes, 10 on this one as well. So number 10, in number 10, what we have is two ships leave port at the same time, traveling the same speed of 10 knots. Wave Dancer sails north. The Ocean Princess travels in a northeast direction here. So we want to know how far apart the ships are after 1 hour, 2 hours. How do these answers change if the Wave Dancer travels twice as fast, justifying our answer. So this one here more focused on getting the setup of this right. So whenever you're doing questions with a direction setup, I usually like to make a little compass just so I don't make mistakes on setting it up. So they're both starting from the same port down here, and one is traveling north. That would be the Wave Dancer, so it's going straight north here for W, and then the Ocean Princess is traveling northeast, so that's going to be in that northeast direction. So in between there's east, so northeast direction here. And this is our ocean pearl. And we want to know how far apart they are. So this is side P. So we want to know side P. Now they're traveling at 10 knots, so how far have they gone? Well, this one's gone 10 knots, and this side is 10 knots. And that's all they give us. Now that doesn't give us an explicit angle, and so that can be confusing. But the direction is northeast, and when you look at the compass, and I don't know if I actually showed you. I didn't switch that, sorry. That's my diagram. My apologies. But in the case of traveling in a northeasterly direction, northeast is directly between north and east, and there's a 90-degree angle between north and east, so northeast is at 45 degrees. So northeast is 45 degrees off of north, or 45 degrees off of east. So that angle there is 45. Thus, we can find that distance using the cosine law, so it would just be the p squared equals 10 squared plus 10 squared minus 2 times 10 times 10 times cosine 45. And then we just fill all that in. And again, you can put that all in our calculator. And you get 58.6. And then we just take the square root to get the p-value. And that works out to about 7.7 knots. So they're about 7.7 knots apart. And the next part said, how far apart are they after 2 hours? Well, what we do is the exact same thing. However, we would double the tens here. So these would become 20 because they're traveling at 10 knots an hour. So they're going to be it's going to be double that, and so you can multiply each of those by 2, and then again it'd be a very similar setup. It'd be p squared equals 20 squared plus 20 squared minus 2 times 20 times 20 times the cosine of 45. In that case, it's 234.3. So we take the square root of that, and we get 15.3. And so it's approximately twice as far apart. Now the next part said, how do these answers change if the wave dancer travels twice as fast? And justify your answer. So if the wave dancer was traveling twice as fast, then this side would be twice as long. You would likely start to see a greater increase in the size of that side P, because it would just have a greater distance between them. But you can check that out and justify it yourself by just plopping those into a calculator. Using 20 and 10 as your side lengths instead of 10 and 10. The last part here I want to take a look at is just the finding angles with the cosine law. So a couple questions. What questions we have? There was 2, 9, and 10. I just want to take a look at questions number 9 and 10 for that. So we take a look here. Question number 9 is talking about a distress signal received from a ship that is 21 kilometers from one port, 17 kilometers from another port. The eastern port is 24 kilometers directly east of the western port. At what angle to the western shoreline should the ship head in order to dock at the western port? Round the answer, your answer to the nearest degree here. So here's our ship, here's our ports. We're actually trying to find this angle outside here, which is not within our cosine law formula. Or cosine law will allow us to find an interior angle, any of these interior angles. This exterior angle, though, because this east-west port are directly east-west of each other, we know this line compared to this line. This is a northern line. I'm going straight up here. So this would be considered 90 degrees. So here's the western shoreline. From that western port, what angle do we want to find in here? And they gave us that nice diagram to help us out. So all we're doing here is plugging in those values into the alternative version of the cosine law. Again, you don't have to use the alternative version. You can use the same version we were just using. However, if you have it already rearranged, it's or you just remember it, then this is a much easier formula to use. So it's a squared minus b squared minus c squared all over negative 2bc equals the cosine a. So we can find our angle by just plugging in all the sides and calculating this. So in our case here it was because we want to work with that western port, the opposite side is going to be opposite angle A. We're looking for that angle at the western port. So our a value here is going to be the 21. So 21 squared minus, and then the other two sides, doesn't matter which order we put them in because they're both being subtracted. And then multiplied on the bottom here. So we just plug all that in, and that'll give us our ratio for cosine A, which we can then find. So again, you can do this all in your calculator. If you're doing this all in your calculator, make sure you put this bottom portion in parentheses because it'll mess up your division otherwise. Or you can do it in 2 steps, do the top, do the bottom, which I'll do here for you guys. So 21 squared minus 17 squared minus 24 squared. It's going to give us negative 424. Okay, and you should be getting a negative number here as you're dividing by a negative, which will then flip it to positive. There are cases where you do get negative cosine, however, it is outside of the normal 90 degree area that we're working with. You'll see that as you move into grade 11 math, and you start working with angles within a circle. And so we got negative 816 here on the bottom, once I work that out. So just divide those two numbers, negative 424 divided by negative 816. It's going to give us 0.5196, rounding to 4 decimal places. And then I can press my second cos or look that up in the table of values. And as I look that up in the table of values, what I'm finding is I get about 59 degrees. .59 equals A. So notice that again the cos disappeared now. Once I calculated the angle from the ratio, the cos portion disappears. Cos is a calculation that we did. So we're left with 59 degrees here. Now, going back to our image here, 59 is the angle inside. We need the outside angle here up to 90. So 90 minus 59 is what you're going to do here, and you'll get your 31 degrees as your actual answer. So the answer here should be 31 degrees when you finish that one off. The next one was number 10, I believe. Yeah, number 10. So number 10, we have a leaning pole is braced at its midpoint as shown. The pole is 8.2 meters long and bracing beam is 6 meters long. The foot of the beam is placed 5 meters from the base of the pole. Determine to the nearest degree the angle the pole makes with the ground, the angle the beam makes with the ground, the angle the beam makes with the pole. So we want to find all these different angles in here. So to do that, we can set up the cosine law. We know the length of the pole here. We know the length on the ground here is 5 meters. This side here is not 8.2. The whole thing is 8.2. It's at the midpoint, so this is only a 4.1 as our side. So when we're looking for the angle the pole makes with the ground, what you're going to do is look at this angle down here. And so the A value in the formula is going to be 6 in this case. And each time the A value is going to change. So the A value for the first part A is 6. The A value in part B is going to be the 4.1, and then in part C it will be this angle up here, and that's going to be the 5. And you're just going to roll through each of those as you're doing those calculations. I'm going to leave you guys to calculate that one. Again, it's just the same as previous. There we go. So you're just going to fill in that formula, changing the A, B, and C value around each time, and that will give you your 3 angles that you're looking for there to find the missing side or missing angles in there. So again, the big thing is just picking out. The formulas aren't all overly complex. It's just a matter of picking out when to use them. So again, remember the sine law. You're using that when you have a pair of sides and their opposite angles. And the cosine law, you either have all 3 sides, like we did for this last set of questions, or you have 2 sides and the angle contained in between them. So that angle is in between the sides in that kind of V that they make. And you're looking for the opposite side. So hope that helps out. Next week, I believe, is our last video. We'll take a look at just solving problems using trigonometry. Those of you that are looking at that, that is a mix of everything. So there is right and non-right triangles mixed in there, sometimes together. Maybe in some of those problems. So you're using the sine, cosine, and tangent ratios, as well as the sine law and cosine law. Again, if you have questions in between now and then, feel free to send me a message on Edsby or via email, and I will try and help you out. Otherwise, have a good week.